Good morning, friends. I am here with a new video which is related to the boiler fuel oil combustion as discussed earlier. In the previous video, I told you guys that I am going to come with a new video which is related with the boiler fuel oil combustion. How the flames are being formed, primary flame, secondary flame, what are the swirl plate function, tip plate function. So all these things we are going to discuss in this video. Okay, now we will discuss about the combustion stages of fuel in the boiler. What are the different combustion stages? How the fuel gets burned into the boiler burner furnace. Okay, so as we know that when we talk about the heavy fuel oil, it needs the preheating part, and preheating basically reduces the viscosity. Okay, so preheating and preparation phase. So the liquid fuel is heated to reduce the viscosity and then broken down. That is something which is called atomized into the fine droplets. And it provides a large surface area, because when we talk about the atomization provides the large surface area for mixing with air and facilitates the evaporation of flammable vapors. Note, now we have to keep something in mind also. When we are doing the preheating, we should not overheat this, because overheating will cause a process which is called cracking. I hope you have heard earlier fuel cracking. So overheating should be avoided. Otherwise, it will lead to the formation of carbon deposits and the gases in fuel oil pipelines. And then again, few gases in means that means the flammable vapors, and these vapors are having very large volume, and then this restricts the mass of the liquid fuel oil supply in the pipeline, because when we talk about the fuel oil pipeline, the volumetric capacity is basically fixed as per the cross sectional area. So the gases will be filled up and the fuel oil supply will be reduced. And due to this reduction, basically, the steaming rate will also reduce, because in actual we are burning less amount of the fuel. So due to these gases which filled up the pipeline. Again, due to the gasification in pipeline, it causes the instability in combustion process as the result in fluctuating flame formation. So we have the gaseous formation, less fuel it is going, and the fluctuating flame is also being produced. And after that, if it continues for longer time, then flame trip is also happening. This is also quite possible. The next stage is basically your automation. The heated oil is passed through the burner and it is atomized. So we know that what is the purpose of automation: breaking of the fuel into fine droplets, and this increases the surface area and helps in the proper combustion. So it creates basically fine spray of the droplets, and this present a very large area for the proper combustion. But again, the droplets which are being formed over here are of basically two types. What are the types? Number one, very fine droplets, which is consisting of the lighter fraction of the fuel, and another one which is there is slightly larger droplets, which consist of the heavier fraction of the fuel. Means lighter fraction and heavier fraction both are there in that part after automation. Now we will discuss about the various combustion stages of fuel in the boiler. Now I will show you the diagram. In this diagram, it is explained in a better manner. You can see here, first of all, we will see what are the major parts of it. As you can see, this is the complete boiler burner assembly. Here, this is your boiler casing in which the boiler burner assembly is being fixed over here. This is your refractory coil, and in this one, you can see here the primary flame is being consisting of, and after that you have the secondary flame, and the complete primary flame plus secondary flame is called suspended flame. Okay, so here we can see this is the swirl vanes which is being provided, and you have the tip plate which is there. So everything is having function. Here you can see this how secondary air is passing through it and creating the secondary flame, and the primary air is passing through it and creating the primary flame, which is well within the refractory coil. So we will see afterwards what is the function of refractory coil, what is the function of tip plate. All these things we are going to see. And here one thing we have to keep in mind, the product of combustion, that is the flue gas. So this consists of the water vapor, carbon dioxide, sulfur dioxide, nitrogen, and excess air, and in the poor combustion, carbon monoxide also. So that is also going out. Okay. Formation of hollow rotating cone of the oil droplets. So now the fuel which is coming out and atomized, so this will form a hollow rotating cone, as we have seen earlier in the video of the pressure jet burner or the your normal rotating cup burner. So there also we have the hollow rotating cone produced, and this is basically mixed with the air and burned in the furnace space. The stream of oil particle and the air now enters into the combustion zone at the same rate as the combustion product leaves the combustion space. So we have seen earlier the combustion products, that is your flue gases, it is passing throughout, and the new fuel which is coming and atomized and mixing with air for burning in the combustion space. So basically the flame front which is there, that remains stationary. That I want to stress upon, and I want to make you guys understand that flame front will be remain stationary. Combustion products will be going out, that is flue gases will be going out, and new fuel is coming, and the flame front will remain stationary. Okay. Now the combustion zone, that is divided into two main stages, primary flame and secondary flame, as we have seen in the diagram. So this is the two part. Okay, now we will try to understand the primary flame in the boiler. So what are the function of primary flame and how it is formed? Okay, so primary flame, it requires the oil to be burned must be raised to the ignition temperature. The temperature is such that continuous vaporization of oil is required for the combustion to take place. So basically, when we know that normal flash point, the flammable vapors are formed and the flashes are being occurred. But here what we have to do, we have to need the continuous vaporization of oil for the continuous burning and creation of primary flame. So it needs about 20 degrees centigrade more than the flash point of that particular oil. Okay. So the heat radiated from the flame itself is utilized for this purpose. Means the vaporization is done by the heat radiated by the burner flame at this stage. Now the cone of atomized oil leave the burner. The lighter hydrocarbons are rapidly raised to this temperature as it gets the heat from the furnace flame itself, and then they form the primary flame. After the vaporization, sufficient vapors will be formed and the primary flame is being formed. The heat from the primary flame is now utilized to heat the heavier fraction of fuel to their ignition temperature. Means the heavier fraction we have seen earlier, the lighter and heavier fractions. So now the primary flame is providing the sufficient heat for the heavier fraction fuel also, and they together with the secondary combustion air which is coming and forming the air fuel mixture and passing through the flame and sufficiently heated up to form the secondary flame. Now the purpose of refractory coil. Okay, so as we have seen, it is placed around the primary flame, or you can say rather the primary flame has to be well within the refractory coil. So the primary flame should just fill the coil. Why? Because the heat which is radiated back by the primary flame, radiated by the primary flame is radiated back by the coil, and basically it provides the sufficient heat to the primary flame and makes the primary flame stable. It ensures that the primary flame is stable and not overcooled by the air, because through that the secondary air is also passing in that area, and chances are that it makes the primary flame overcooled, and then the stability is at stake. So if there is too much clearance, the excessive amount of relatively cool secondary air will enter into the furnace. And due to this, what happened? The droplets, the heavier droplets will not get the sufficient heat generated by the primary flame, and the proper you can say the formation of the flammable vapors will not happen, and then the proper combustion will not happen. And basically, due to the air velocity, it will impinge on the coil and form the oil deposits, which is maybe one of the cause of the uh, backfire in the boiler. Okay. Now, what is the purpose of tip plate? The tip plate ensure two things. Number one, correct proportion of the primary air mixing with the fuel, so air fuel mixing ratio, and the correct velocity of the primary air. So basically, the primary air mixing properly with the fuel and with the proper velocity, because earlier we have seen the amount of air fuel which is coming to the furnace and amount of air fuel which is leaving to the furnace, it should be the same almost. So the tip plate spills the primary air over into the series of vortices. So the function basically the provided by the tip plate is to create the vortices, or you can say rather the turbulence sort of thing. And due to this, what happened? The correct mixing of the air and fuel, which is properly atomized, the fuel and air will be correct mixing. And by reducing, it reduces the forward speed of the air also, because it creates a hindrance and it creates the turbulence. So what will happen? The primary air will be near about that, and it helps maintaining the primary air inside the coil, and due to which the primary flame will also be within the coil, and primary flame will be stable. Now we will talk about the secondary flame in the boiler. The secondary flame, it is having the larger droplets, because the finer droplets is properly utilized by the primary flame. So the secondary flame, larger droplets heated into this passage with the primary flame jode and vaporizes the oil, form the flammable vapors. So the steady air supply, which must be there to mix thoroughly with the fuel droplets, and formation of the steady flame will be there. The stability of the suspended secondary flame is largely depend upon two aspects. What are the two aspects? Number one, which we have seen, the forward velocity of the air and the fuel. So air and fuel both which is mixed. So how much is the velocity of the secondary air? That is basically creating the length of the suspended secondary flame. If it is more, then what will happen? Basically, it will go and hit on the other side of the refractory material. So it should not exceed the flame propagation speed. So then it will be stabilized and maintain the suspended flame. If it exceeds, then flame front will move further out into the furnace, and primary flame will now burn outside the coil. So what will happen if this flame front moves further? So this is burning outside the coil, primary flame, and then normal the stabilization of the primary flame will not be there. So it results in overcooling of the flame and creates the instability of the flame. So which we have seen earlier also. Okay, so combustion process we have seen earlier, the primary flame, secondary flame, the stabilization of the primary flame, the flame, suspended flame creation, everything we have seen. Now, with the careful design of the swirl vanes, we have seen earlier the swirl vanes in the diagram or in the air resistor. This can be used to create the required flow pattern in secondary air system. So basically, the swirl vanes are utilized to create the secondary air pattern, means amount of the air flow. All these things are being controlled. So basically, it gives the heat to the furnace for the generation of steam. So we have seen earlier the secondary flame formation and the suspended flame creation, and this is basically creating the sufficient heat and inside the furnace and creating the steam. Sufficient time must be given to complete combustion to take place before unburned oil particles impinge into the tubes of refractory material. So, basically, if the suspended flame length will be more, so along with the secondary air, the droplets will impinge on the other side of the uh, burner front on the refractory material, and this is of just creating a deposits. These require certain amount of the excess air must be supplied. So for that, what we have to do, we have to make sure the some little bit more amount of the air must be supplied so that the proper combustion to take place. So this is also kept in mind. Design of the furnace, efficiency of the combustion process as per the load condition. These are the basically three factors which decides the amount of excess air which needs to be supplied for the proper combustion of fuel. This excess air will reduce the boiler efficiency by some chance, but we cannot uh, take much chance because we need a proper combustion and proper heat development for the steam generation rate. But what happens if this excess air will pass through it? It reduces the boiler efficiency because it carries away the heat also from the furnace to the funnel. So the heat which basically should be utilized in the furnace thrown out through the funnel to atmosphere if the excessive air. So amount of excessive air also has to be well calculated. And now it also, when we talk about this, leads to the increase in the deposits in uptake, because along with that, this the flue gases will also go out, and with that the unburned fuel carbon particle, if it is there, it also go up and creates the deposit in the uptake. And this excessive air basically give excess oxygen to form sulfur trioxide, and this trioxide is also creating a maximum deposits in the uptake. So in this video, I have basically discussed the complete combustion process in the furnace. So I hope whatever I have described in this video, the automation, the process of automation, the refractory coil purpose, the tip plate function, swirl vane function, and what are the factors we have to keep in mind for the proper combustion of the fuel inside the furnace. I hope this is going to help you out to understand the combustion process inside the boiler furnace. Thank you all of you. We will meet in the next video with some other topic. Thank you again.